Hello, and welcome to Astronomy 100. In our last segment, we started talking about Galileo and how Galileo's observations through the newly invented telescope were going to work its way towards changing our understanding of the universe. These observations are critical because these are observations of the celestial bodies that previously had not been able to be possible and would reveal things about the universe in ways that people, of course, would never imagine. In the fall of 1609, Galileo turns his telescope to the planet Saturn. Now, if you remember, the word planet simply means wandering star. And for many, many years, it was believed that all 5 of the planets were stars that just wandered in a way that had not been anything that the constellation stars were able to do, so that these wandering stars, or these planets, were the work of the gods. This picture you see on the screen here is an image of Saturn through a telescope that is very much like the telescope that Galileo used back in the year 1609. If this were an image through a telescope today, we'd be concerned about the telescope. The image is actually very poor. But when the telescope is first invented, of course, optics are still very primitive and the telescopes are very low quality. But here's what I want you to notice. In this image of Saturn, what you can see, although the image is of low quality, is that this is clearly not a star. So as an example, let me show you what a star looks like through a telescope. Through a telescope, a star simply looks like a brighter version of what you see with your eyes. And so what Galileo discovers is that Saturn is not a star. It is not a wandering star. It is a body that is a spherical body, just like the Earth is. You'll notice it has a disk, and of course something on either side of the disk, but it is very much not a star, and it is something more reminiscent of the Earth or the Moon. So Galileo is starting to understand that wandering stars are actually not wandering stars at all. These planets, these wandering stars, are actually worlds, something very much like the Earth. In the observations of Saturn, though, Galileo is confused by what the objects that seem to flank either side of Saturn are. Now, you have to understand, here we are in our modern world, we have a complete understanding of what Galileo sees through his telescope. But 400 years ago, this was knowledge that we had not acquired yet. And so what we were actually seeing through the telescope are the rings of Saturn. And these rings are quite magnificent. If you were to see these rings through at least more modern eyes, you can see that the ring system is quite elaborate. In this image here at the bottom, this is taken from the Cassini spacecraft as it was approaching Saturn, eventually entering into orbit around Saturn. But the ring systems that we understand today, the ring system of Saturn, is something that was unimaginable 400 years ago. And so Galileo is not sure what he's seeing on either side of Saturn. But remember that the assumption that had been made by Ptolemy 1,500 years prior to this point in history was that all celestial bodies must revolve around the Earth in the geocentric model. But clearly Saturn has something revolving around it rather than the Earth. And you can see that the scientists of the era, the scientists of the 17th century, spent quite a bit of time trying to figure out what it actually is that is going around Saturn. And you can see in these particular examples the scientific method at work, essentially, people trying to come up with alternative explanations that could be the correct explanation as to what goes around Saturn. Now, unfortunately, Galileo would die before we would finally figure out that the ring system is just a series of individual particles that are all collectively going around Saturn. But the observations of Saturn as a world, as a spherical body that's not a star, not a wandering star, was critical. And the observation that something was going around Saturn and not the Earth, and that it was an example of a universe that is not geocentric, was also a critical part of this observation. The next object that Galileo points his telescope at is the planet Venus. And once again, he discovers that Venus is not a star, as the name planet or wandering star suggests. What Galileo discovers through his telescope is something that I'm going to show you through a time-lapse movie here, or an animation. These are all images taken of Venus over a period of time. So imagine going outside night after night after night, taking another image, next night taking another image, and then running them all together as a sequence to make the animation that you see here. Through the telescope, Galileo discovered that Venus does two important things. You'll notice that Venus is changing its size as time goes by, going from smaller to larger, back to smaller again. But also notice that Venus is showing a phase. So the phases, the shapes of Venus that you see in this animation are very much the phases that our moon shows. You can even use the same words. We can talk about new or crescent or quarter or gibbous or full. Now what I want you to do is put two things together. Notice that the size and the phase have a correlation. So when the phase is full is when the size is small, and when the phase is new is when the size is big. So notice small, full, and then new right there is when it's largest. So these observations of Venus were quite puzzling to Galileo, because up until the point of this observation, it was believed that the universe had certain basic assumptions that described the workings of the universe itself. So Galileo, of course, is the scientist trying to put together observations with explanation. And let me show you one more piece of the puzzle here. Here are the still images to show you this connection between the size of Venus through the telescope and its phase, the new phase shown here when it's largest, and then heading towards the full phase when it's smallest. But when you watch Venus in the sky relative to what you see through the telescope, what you would see is what is shown in this animation here. This is the view through the telescope, and you can see the phase change and the size change, and this is where Venus is relative to the Sun. So you can see that Venus is changing its position relative to the Sun, and this is what you would see through the telescope simultaneously. So notice the connection. When Venus is far, at least near the Sun, it looks small, and then as Venus gets further and further away from the Sun, it gets bigger and bigger and bigger as the phase changes. Up until the time of Galileo, it was believed that the explanation of our universe was the one put forth by Ptolemy. This was the Ptolemaic system, where Ptolemy describes how the Earth and the Sun have a line that connect the two of them together, and that Venus was on an epicycle, going around and around, but the center of Venus's epicycle was perpetually locked on this line. And if you recall, this keeps Venus always near the Sun, as you see in the sky, and it keeps Venus visible only after sunset and only right before sunrise. So this assumption that was made about the Earth and Venus and the Sun had been in place for 15 centuries. Now, Galileo comes along and says, well, if this is true, from the perspective of the Earth, looking towards where the Sun is, here is that line that keeps those two objects perpetually together. And here is, of course, the epicycle of Venus, as you would see going around and around, always centered on this line. But you'll notice that Venus, moving on this epicycle, is going to show just a few of the shapes that you see through the telescope. For instance, you can see that Venus will show a crescent shape. If Venus were here, it would be new. If Venus were here, it would be new. But notice that you can't ever get gibbous, you can't ever have full, and so if Venus is truly on an epicycle, locked between the Earth and the Sun, it won't match what you actually see through the telescope when you look at Venus in the sky. However, if it is a heliocentric universe with the Sun at the center and Venus in orbit around the Sun as a planet, like the Earth is, then what you'll notice is that Venus can show all phases, and when Venus is smallest will be full, and when Venus is largest will be the phase of new. So the only explanation that fits the observations of Venus is the heliocentric model. And that's the way the scientific method works. Your explanation is only considered to be correct if it's supported by all of the evidence. And here was observational evidence to support the heliocentric model and to refute the geocentric model. So the discovery of how Venus looks through a telescope changing its size and its phase was a very critical one in our effort to try to get a decision based on observations as to which model is correct, geocentric or heliocentric. Now, the last observation that Galileo makes is in the early years of 1610, and he points his telescope to the planet Jupiter. And in this picture you see here on the screen, this is again the view of Jupiter that you would get through a very primitive telescope, such as the one that Galileo had. Venus shows different phases and sizes. Saturn showed the rings. Jupiter shows these stripes. So you'll notice the striped features on the surface of Jupiter. But it wasn't really the surface features of Jupiter that got the attention of Galileo. What really got his attention was on the first night of his observation, he noticed what seemed to be 4 stars in the background, as you can see in this picture here. Now, it's not improbable or unlikely to have stars in the background of an observation of a planet. It's just something that occasionally happens. But what I want you to notice is in his logbook, as he's recording what he sees through the telescope, he shows that Jupiter, on various days, each of these lines is a different day. Jupiter, of course, is the circle that goes down the middle. But these background stars turn out to move over time. So here you can see 3 of them on one side, here are 2 of them on one side, here are 2 on one side, 1 on the other, here are 3 of them on the left side. So as day after day after day goes by, Galileo discovers that these background objects are actually moving, but they're moving with Jupiter. Now, here we are in our modern world, we would say, but of course, Jupiter has moons going around it. But 400 years ago, this was unthinkable. There was only one moon in our universe, and that was the Earth's moon. So in early 1610, Galileo discovers that there are 4 moons orbiting around Jupiter. And this discovery would make him instantly famous. The discovery of other bodies in our solar system orbiting around other bodies was something that was just hard for the public to imagine, but yet here he has discovered 4 new bodies in our solar system. And to make things more interesting, these 4 new bodies were going around Jupiter. So the moons of Jupiter demonstrated that the geocentric assumption that all celestial bodies have to revolve around the Earth is clearly wrong, that Jupiter has 4 moons and that these 4 moons orbit around Jupiter and not the Earth. The last component of this discovery of the moons of Jupiter would turn out to be the one that finally puts all of the ideas of geocentrism to rest. And let me show you what I mean by that. In this illustration that you see here, what we have is the Earth in its orbit around the Sun. One of the arguments that the ancient people made about the concept of geocentrism and the possibility of the Sun being the center, or heliocentrism, the argument was that if the Sun truly was the center of all things, and if the Earth orbited around the Sun, not the other way around, then it would be impossible to have the moon go around the Earth and stay going around the Earth. In the minds of the ancient Greeks, if the Earth physically moved, then it would be impossible for the moon to continue to orbit around the Earth, but instead, as the Earth moved, the moon would wander away. So in other words, from this position to this position would force the moon to leave the orbit of the Earth and then wander off into the universe. And since the moon clearly stays in its orbit around the Earth, that seemed in their minds to prove that the Earth could not move, that the Earth had to be a stationary body. But here were observations of moons going around Jupiter. And obviously Jupiter moves. Even in the geocentric model, it's believed that Jupiter goes around the Earth. So the movement of Jupiter, whether it's around the Earth or around the Sun, the planet Jupiter is clearly able to keep the moons in orbit around it as it physically moves through the universe. So the argument that you can't have an orbiting body orbiting around another body that's moving, that argument is just simply wrong. And it's able to show that this one major assumption about the geocentric model was simply incorrect. So the observations of the moons of Jupiter were a critical step forward in proving heliocentrism and disproving geocentrism. Now, all of this would of course make Galileo somebody very famous, and when it comes to the history of this, I guess you could say infamous as well. The Roman Catholic Church was not very pleased with these observations because these observations seemed to contradict the words of the religions of the day, and so the Roman Catholic Church persecuted Galileo for his discoveries. They outlawed the use of the telescope. They did everything in their power to try to keep the public from seeing these things themselves, because if you recall, the concept of geocentrism was one that the church supported. Heliocentrism was considered heresy. But eventually, the church can't do anything to stop this. And so eventually, as people see these things themselves through the telescope, they were able to see that the heliocentric model is the preferred one. Galileo publishes his book describing all of his observations. This would turn out to be one of the most historically significant books related to astronomy of all times. The book is called Sidereus Nuncius, which means the starry messenger. And in his book, he describes all of his discoveries that he's made looking through the telescope, seeing the ways of the universe. But of course, he also is describing how geocentrism is essentially incorrect and that heliocentrism is the correct interpretation of the universe. Now, this gets Galileo into trouble with the church. Living in Italy in the early part of the 17th century, the Roman Catholic Church, of course, is still very powerful. And Galileo, although he's not trying to run afoul of the church, just the very concept of his discoveries and the heliocentric interpretation means that the church is going to look very poorly upon this. And so, as the book, of course, becomes very famous, more and more people read the book, the concept of geocentrism is just clearly and obviously wrong. And that this book is something that makes Galileo famous. It's a book that everybody wants to read, everybody wants to own. The church works very hard to forbid the book, to keep people from having it. But as people with their own telescopes can see these things for themselves, it becomes very obvious that heliocentrism is the correct interpretation. And finally, after 2,000 years, geocentrism is finally put to bed.